All right, taking a look at quiz 1. For this first one, rank the bonds below from most reactive to least reactive. This was one of the harder questions on the quiz. The I2 is actually the most reactive because those atoms are so large. There'll be less orbital overlap and then longer bond. So those make those most reactive. So it's just the opposite. 1 and then fluorine would be the least reactive because they have shorter bond, so it makes it less reactive. So that's what the picture I wanted here was to show me something like this, where you can see the two atoms bonding, less orbital overlap. Here, Lewis structure. Again, make sure the nitrogen's the middle atom. The hydrogens usually never bond to the middle atom. So +1 for lone pairs, +1 for structure. Moving down, this one was just taking into account that we learned that if something, or the easy ones were, this is sp3 hybridized, has no pi bonds, that carbon. This carbon has 1 pi bond, so it's sp2, so it has to have 1 p orbital. This oxygen ends up being sp2 hybridized because it wants to do resonance. So it's going to choose to be sp2 hybridized, so then it has a p orbital. So we can put one of its lone pairs into the p orbital, because you have to be in a p orbital or in a pi bond to do resonance. So that's why it's choosing to do that. So one of its lone pairs is a p orbital, the other lone pair is an sp2 hybrid orbital. But then if you look at this oxygen is sp2 hybridized. So one of its p orbital is being used for a pi bond. So these two lone pairs are both in sp2 hybrid orbitals. It's a little different. So recognizing that if something can do resonance, an atom can do resonance, it will want to, and that will affect its hybridization state. So normally this oxygen would be sp3, but it's choosing to be sp2, so it has a p orbital, can put a lone pair in it, and then that can do resonance. All right, last one here, nirmatrelvir, which is a part of the new COVID-19 Paxlovid treatment. So I want you to draw all the lone pairs. So some folks forgot the fluorines, different places along the way. Make sure you do that. And then draw resonance structures. Didn't need to redraw everything. Lots of resonance forms. Showed the nitrogen lone pair. This nitrogen is choosing to be sp2 hybridized. Has a p orbital. Lone pairs in that p orbital. You can do resonance there. Some folks did resonance here, so it'll be a plus charge on the carbon. A lot of it was either this is the only other place, or they could do just a pi bond breaking, plus charge on the carbon. As long as you balanced your charge and had arrows, that's the key. So I wanted 2 of those at least.